We were able to deflect an asteroid in this way. DART mission. The DART mission, a spacecraft that purposefully collided with an asteroid to shift its orbit, is responsible for deflecting an asteroid for the first time in history. This is not a scene from a science fiction film. Do you want to know how he achieved it and what effects it might have on the planet? Let's begin. On September 26th of this year, NASA tested the DART mission, which consisted of a 610-kilogram spacecraft with no payload, in contrast to missions like space exploration probes, which carry a number of crucial scientific instruments. The DART mission's main goal was to strike an asteroid. The mission also included a tiny CubeSat, a small cubic ship that is designed to observe a specific event. In this case, the CubeSat installed by the Italian Space Agency was on board with the intention of attempting to capture images of the impact and ejecta as it passes by the asteroid and sending that information to Earth. The DART mission launched on November 24, 2021, from the Vandenberg Space Station in the United States and traveled for a year, covering over 1 million kilometers, to its destination, the binary asteroid Didymos. The asteroid system, the asteroid Dimorphos, which has a diameter of 170 meters, and orbits Didymos, which has a diameter of 780 meters, is the target of the DART mission. Dimorphos is categorized as a binary asteroid since it circled Didymos every 11 days as if it were its moon. Why did this asteroid get chosen over others? First, by deflecting this asteroid, changes in its velocity can be determined by watching as Dimorphos passes in front of Didymos. This will cause a dip in light that can be noticed by ground-based telescopes and will allow for an accurate measurement of how much has deviated. Dimorphos was also picked because it is the right size. We will talk more about this later. It is in the size range of Apollo-type asteroids, which are the ones that pose the most immediate threat to Earth. Additionally, it was selected because the binary asteroid system was relatively close to the Earth at the time. Finally, and perhaps most importantly, Dimorphos' orbit can be changed without endangering the Earth because it will still continue to orbit Didymos and stay within the binary asteroid system. The Planetary Defense Coordination Office claims that this binary system is actually ideal for testing planetary defense technology and acts as a laboratory where we may conduct experiments without endangering our planet. Punch of truth: the DART spacecraft spent a year traveling a great distance from Earth to its meeting with the asteroid Dimorphos before making contact with it. Although it appears like a long voyage, it is within the range of the majority of the asteroids that are a threat to the Earth. The DART spacecraft arrived at its destination on September 26th. The solar panels were pointing in the right direction, the rockets were firing at full strength, and the point of impact was designated. Several telescopes on Earth were keeping an eye on the situation to gather as much information as they could. The spacecraft made a rapid approach before finally colliding with the asteroid, launching several materials into orbit that were visible through telescopes on Earth. We still don't know if that hit will be sufficient to alter the asteroid's orbit. We'll have to wait a few weeks to find out. The DART impactor's main goal is to slightly, barely, slow the asteroid's speed, but why would you want to do that? Unbeknownst to many, this is one of the best methods for deflecting asteroids. When an asteroid is found to be coming toward Earth, all it takes to prevent it from colliding with the planet is to slightly deflect it, either by delaying it or hastening its orbit around the Sun. This is what is referred to as an asteroid redirection mission. In the case of the DART mission, the goal is to hit head-on with Dimorphos in order to significantly alter its end course relative to its initial trajectory over a number of orbits collected over weeks, months, or years. The method we would use to divert an asteroid from Earth is the same. Do these kinds of asteroids create a hazard? It is categorized as a NEO asteroid, Didymos. The asteroids known as NEOs, or near-Earth objects, occasionally cross Earth's orbit. According to the most cautious estimates, there are currently roughly 70 million of these asteroids orbiting close to the Earth. The binary system of Didymos is an Apollo-type asteroid, which is a category of asteroids that are in the Earth's orbit and occasionally come quite close to our planet. However, rest assured that most of these asteroids are the size of a home, which is not exactly good news considering that the 2013 Chelyabinsk bolide was only an Apollo-type asteroid, and we are all aware of the devastation it did. Fortunately, it appears that none of these asteroids are headed directly for Earth. We can only pray that none of the thousands of these types of asteroids that we have yet to find would strike Earth right now, given the sad and unsettling reality that there are still thousands of them out there. Can a space object this large wipe out the entire planet? However, none of the asteroid dimorphos or Didymos, which have diameters of 170 and 780 meters respectively, can completely destroy the planet due to their small sizes. If an asteroid the size of Dimorphos, which has a diameter of 170 meters, were to strike Earth, it could instantly wipe out many nations and kill millions of people. If an asteroid the size of Didymos were to strike Earth, it might wipe out an entire continent and seriously harm the ecology on a global scale. As you can see, while asteroids of this size cannot completely destroy the Earth, they can do terrible harm to the environment and wipe out a great number of living beings. What's the worst thing, you ask? The worst part is that these are the exact asteroids that astronomers are most worried about. Because asteroid discovery graphs show that when we first began scanning the sky for asteroids in the 1940s, we initially discovered many large asteroids similar to Didymos. Observational astronomers believe that all large asteroids like Didymos have already been discovered and there are no more to discover. Even so, we have ceased finding large asteroids over time, but we still detect minor asteroids on a regular basis. Despite significant advancements in observational technology, such as space telescopes and astronomical observatories, we are no longer discovering massive asteroids. The most straightforward reason for this is because we are already aware of all of them. Small asteroids, on the other hand, keep showing up, thus this is not true. Small portions of Earth are threatened by small asteroids, even though they do not constitute a threat to all life on Earth. Deflecting this asteroid is an exceptional feat for planetary security because the majority of these asteroids that are still being discovered are smaller than Dimorphos. In the following years, if we can divert Dimorphos, we may also be able to divert another potentially hazardous asteroid that is headed for Earth. An important step for world defense. This is not the first time in history that a human-made object has collided with an asteroid. The Deep Impact spacecraft launched an impact in 2005 that struck the comet Tempel 1's nucleus in the first test of this maneuver. Although the comet's trajectory was not altered by this hit, it was nevertheless useful for the DART mission. Assume that planetary defense technology keeps developing as it has in the past. The only thing that is definite in this situation is that in the years to come, there will be more missions like this one, which aid in our defense against dangers from space and help us avoid what occurred 65 million years ago to the dinosaurs. Alright everyone, this is it for now. Thanks for watching and make sure to like our video and subscribe to our channel as it encourages us to keep making amazing videos like this for you.